the things that you've got to have in a dissociation equation. You have to have the fact that this thing is a solid. If we are saying that this is a dissociation equation, then by definition, the first thing you've got is going to be a solid. Does that help?
Yes.
Okay. By definition, if we're starting with a dissociation equation, the first thing is going to be a solid. We're going to have a line that has H2O over it, which tells us that this is dissociation. This is not a decomposition reaction, because otherwise it kind of looks like that. That H2O tells you, yeah, this is not a decomposition reaction. This is dissociation in water. That H2O has to be there. So then we're going to have the two ions that this is breaking up into. As long as this is H2O, this is always going to be aqueous solution, because an aqueous solution is a solution that has what as the solvent? Water. Okay, so we have a plus because we're getting potassium ions. We're also here getting hydroxide ions, and they're also going to be an aqueous solution. So does that make sense? Okay, let's do the next one. Okay, so we've got ammonium chromate here, NH4 2 times CrO4 as a solid. It's going to dissociate, so we're going to put our H2O over the bar. Now, what are the ions this can break into? Well, ammonium, which is a 1 plus, and chromate, which is a 2 minus. At this point, are the charges balanced? Are the ions balanced? No, because in every mole of ammonium chromate, there were 2 moles of ammonium ions. Okay, so now we've got 2 ammonium ions over here, 2 ammonium ions over here, 1 chromate ion over here, 1 chromate ion over there. Do the charges balance? We've got 2 plus, we've got 2 minus, because this is 2 times the 1 plus. Okay, so that's good. You cannot break that chromate ion down into other stuff. The minute you do that, you're not doing a dissociation anymore. You're now into the realm of decomposition reactions of some sort. We can't predict what's going to happen there. So that is just dissociation. Just finding the ions and splitting them apart. Okay, so now we have magnesium cyanide, MgCN 2 times. Again, we're going to put our arrow with our H2O to dissociate this. There are 2 ions here. There's the magnesium ion, Mg2 plus, and there's the cyanide ion, and the cyanide ion is a 1 minus. How many cyanide ions did we have over here? 2. So we have to have 2 over here. And at this point, we've got 2 plus and 2 times 1 minus. Do our charges balance? Yes. So we're done. Again, if you break that down into carbon and nitrogen or something else, you're no longer doing a dissociation equation. At that point, you're doing decomposition. Whole different thing. Don't do it, can't do it, not going to do it. Does that clarify? Okay, so when we've got something that contains a component which on its own is diatomic, we don't worry about that being diatomic because it's in a compound. We're breaking it down to an ion, and that ion is on its own. So we've got 2 Cl1 minus or 1 Br1 minus. That is not a Cl2.